Hey, welcome back. In our last couple problems, we practiced with using the discriminant, but we didn't find the solutions. This time, we're going to find the discriminant and find the solutions. So, number 18, I'm going to write negative 8b squared. I'm going to write a little space here, plus 17 equals 3. I left a space because there's no regular b term. And since it's not equal to 0, I want to subtract 3 from both sides to get it equal to 0. So I get negative 8b squared plus 0b. There's no b there, which is the same as saying there's 0b. 0 times b is 0. Plus 14 equals 0. And then I can say a equals negative 8, b equals 0, c equals 14. And then I get my discriminant, b squared minus 4ac, and b is 0, 0 squared minus 4 times a, which is negative 8, times c, which is 14. So the 0 squared is just 0, and then a negative times a negative is positive. If you multiply out 4 times 8 times 14, you get 448, and that's the value of our discriminant, 448. So the next thing we do is we go back to our formula, the quadratic formula. I've got a song. My students will recognize the song. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And we substitute in the values that we found. So negative b, or the opposite of b, since b is 0, the opposite of 0 is still 0, plus or minus the square root of the discriminant, which is 448. We've already found it, over 2a, and a is negative 8. Now, we want to check to see if the square root of 448 is a perfect square, to see if it gives us a whole number. It doesn't. It gives us a decimal, so it's irrational. But we want to see if we can simplify it. So we take 448 and we divide it by 2. We want to put in simplest radical form. So 448 divided by 2 is 224. And 224 divided by 2 is 112. And 2 into 112 goes 56 times. And 2 into 56 goes 28 times. 2 into 28 goes 14 times. And 2 into 14 goes 7 times. And since 7 is prime, we stop there, making note that there is 1 pair of 2's, 2 pair of 2's, 3 pair of 2's. Each of those pairs comes out from under the radical as a 2, and they get multiplied. Some students want to add them. 2 plus 2 plus 2 is 6. No, these are multiplied. It's 2 times 2 times 2. So what you get then as a result is plus or minus 8, because 2 times 2 times 2 is 8, square root of 7 over negative 16. And then you want to simplify this. Forget about the radical for just a moment and just look at the other numbers in the numerator and the denominator and simplify that as though that were the fraction. 8 over negative 16. And so that's 1 over negative 2. So this is plus or minus the square root of 7, which has an imaginary 1 in front of it, divide by 2. And again, this is two numbers. Negative square root of 7 over 2 and positive square root of 7 over 2. Or vice versa. If you switch the order, that doesn't matter. So let's look at number 19. 19 is very similar to what we saw in 18. We're going to write this again, 3r squared plus 10 equals negative 2. And we're going to add 2 to both sides. And that's going to give us on the right 0. On the left, it's going to give us 3r squared plus 12. And in between here, I'm going to write plus 0r. I'm going to put a little line there so looks like a 0 instead of an or. And then we can make note, now that it's in standard form, that A equals 3, B equals 0, and C equals 12. So in our discriminant, b squared minus 4ac, b is 0 squared, minus 4 times a, 3 times c, which is 12. And when you put that in your calculator, you do it by hand, that comes out to be negative 144. So our discriminant is negative 144. Since it is negative, we're going to have two imaginary roots, or non-real roots at least. I'm going to write out my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to write this is equal to the opposite of b, which is, there's no positive or negative 0. It's all neutral. So I'm just going to write 0 plus or minus the square root of negative 144 all over 2 times a, and a is 3. Now, 144 is a perfect square, but since it's negative, that comes out as the imaginary number I. So I'm going to write this as plus or minus 12, which is the square root of 144, I, which is the square root of negative 1. And this is all over 2 times 3, which is 6. Again, I can simplify this out a little more here. This is plus or minus 6 goes into 12 2 times, so this is 2i. And so my solutions are negative 2i and positive 2i. All right, let's look at the last problem here. The last problem, number 20, we've got 6x squared equals 24 plus 10x. So I'm going to write this down here as 6x squared. I'm going to leave a space for an x. I'm going to leave a space for a 24 is equal to 24 plus 10x. And then I'm going to subtract 10x from both sides. I'm going to put it right here in that slot where I want it to go. And I'm going to take minus 24, the opposite of 24, and I'm going to subtract it from both sides, again, putting it in the slot where I want it to go. Over on the right, these are going to cancel, leaving 0. And on the left, we've got 6x squared minus 10x minus 24. Now that we have it in standard form, I can say that a equals 6, b equals negative 10, and c equals negative 24. I go to b squared minus 4ac. b is negative 10 squared minus 4 times a is 6, and c, which is negative 24. So negative 10 squared is 100. And here I've got two negatives, so that's multiplied out. 4 times 6 is 24. 24 squared is 256, I think. 24. No, it's 576. So I've got plus 576. And then that's 676. So there's my discriminant. 676. My solutions are going to come from putting it back into the formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, opposite of b, since b is negative 10, the opposite of negative 10 is positive 10. Plus or minus the square root of, and we already calculated it, so we just put 676 in here. And this is all over 2 times a, and a is 6. Now I want to see if the square root of 676 is a perfect square. So I put that in my calculator. the square root of 676, and it is 26. So I get 10 plus or minus 26, and this is all over 2 times 6 or 12. Now, I can break this down into two parts here now. 10 plus 26 over 12, which is 36 over 12, which is 3. And that's one of my solutions. Or 10 minus 26 over 12, and that's 10 minus 26 would be negative 16 over 12, and that simplifies down. They're both divisible by 4, so that's negative 4 thirds. And that's my other solution. And so my two solutions are negative 4 thirds and 3. And that's it. That's the last problem. Practice hard, study. You'll be just fine on the test.